It stands to reason that if the history of life forms a tree, with all species originating from a single trunk, then one can find a common origin for every pair of twigs, existing species, by tracing each twig back through its branches until they intersect at the branch they have in common. This node, as we've seen, is their common ancestor. And if life began with one species and split into millions of descendant species through a branching process, it follows that every pair of species shares a common ancestor sometime in the past. Closely related species, like closely related people, had a common ancestor that lived fairly recently, while the common ancestor of more distantly related species, like that of distant human relatives, lived further back in the past. Thus, the idea of common ancestry, the fourth tenet of Darwinism, is the flip side of speciation. It simply means that we can always look back in time using either DNA sequences or fossils and find descendants joining at their ancestors. Let's examine one evolutionary tree, that of vertebrates. On this tree, I've put some of the features that biologists use to deduce evolutionary relationships. For a start, fish, amphibians, mammals, and reptiles all have a backbone. They are vertebrates, so they must have descended from a common ancestor that also had vertebrae. But within vertebrates, reptiles and mammals are united and distinguished from fish and amphibians by having an amniotic egg. The embryo is surrounded by a fluid-filled membrane called the amnion. So reptiles and mammals must have had a more recent common ancestor that itself possessed such an egg. But this group also contains two subgroups, one with species that all have hair, are warm-blooded and produce milk, that is, mammals, and another with species that are cold-blooded, scaly, and produce watertight eggs, that is, reptiles. Like all species, these form a nested hierarchy, a hierarchy in which big groups of species whose members share a few traits are subdivided into smaller groups of species sharing more traits, and so on down to species like black bears and grizzly bears that share nearly all their traits. Actually, the nested arrangement of life was recognized long before Darwin. Starting with the Swedish botanist Carl Linnaeus in 1635, biologists began classifying animals and plants, discovering that they consistently fell into what was called a natural classification. Strikingly, different biologists came up with nearly identical groupings. This means that these groupings are not subjective artifacts of a human need to classify, but tell us something real and fundamental about nature. But nobody knew what that something was until Darwin came along and showed that the nested arrangement of life is precisely what evolution predicts. Creatures with recent common ancestors share many traits, while those whose common ancestors lay in the distant past are more dissimilar. The natural classification is itself strong evidence for evolution. Until about 30 years ago, biologists used visible features like anatomy and mode of reproduction to reconstruct the ancestry of living species. This was based on the reasonable assumption that organisms with similar features also have similar genes, and thus are more closely related. But now we have a powerful new and independent way to establish ancestry. We can look directly at the genes themselves. By sequencing the DNA of various species and measuring how similar these sequences are, we can reconstruct their evolutionary relationships. Species having more similar DNA are more closely related. That is, their common ancestors lived more recently. Both the visible traits of organisms and their DNA sequences usually give the same information about evolutionary relationships. The idea of common ancestry leads naturally to powerful and testable predictions about evolution. If we see that birds and reptiles group together based on their features and DNA sequences, we can predict that we should find common ancestors of birds and reptiles in the fossil record. Such predictions have been fulfilled, giving some of the strongest evidence for evolution.